moving charges and magnetism. In this first thing that you need to understand, and that is total force experienced by charge when it is moving with velocity v in the presence of electric field and magnetic field. So total force experienced by charge moving with velocity v in the presence of electric and magnetic field is, तो इलेक्ट्रिक एंड मैग्नेटिक फील्ड इज, तो यहाँ पर जो फॉर्मूला होगा इसका वो कितना होगा वो देख लेते हैं एक बार. सो दिस फॉर्मूला इज कॉल्ड एज द लॉरेंट्ज फोर्स, है ना. तो अगर एक चार्ज है विच इज मूविंग विथ वेलोसिटी v, तो इलेक्ट्रिक फील्ड दी है और मैग्नेटिक फील्ड है सपोज टू बी ऑन प्रेजेंट इन द स्पेस. तो ड्यू टू इलेक्ट्रिक फील्ड force will be q into E, and due to magnetic field force will be q into V cross B, and due to this both fields we have what is called as the net force, and that net force is force due to magnetic field plus force due to electric field, and we have force due to magnetic field that's q v bar cross b bar plus force due to electric field is q e bar, and if you just take q common it will be v bar cross b bar plus e bar. So I hope this is clear. So this is called as the Lorentz force. This is the Lorentz force. Next formula we have is force experienced by current carrying conductor having current I and placed in a magnetic field B. So in this case what will be the force experienced? F bar is equal to, we have I L bar cross B bar. Do remember this, I L bar cross B bar. So if you have what is called as the current carrying conductor, and if you place it inside the what is called as the magnetic field, it is then the due to magnetic field and the current we have the force on this wire, and that force is I L bar cross B bar. So this magnitude wise, if you just talk about the magnitude, so it will be I L B sin theta. Next formula we have is the frequency and time period for a charged particle which is moving with velocity v and enters into a magnetic field perpendicularly. तो अगर ये एक मैग्नेटिक फील्ड है और इस मैग्नेटिक फील्ड में अगर एक चार्ज पार्टिकल आ जाता है परपेंडिकुलर टू इट्स डायरेक्शन, देन इसके ऊपर एक फोर्स लगेगा, इसके ऊपर फोर्स लगेगा ऊपर की तरफ, सो दैट इट विल गो इनटू दिस सर्कल, और इसका रेडियस कुछ होगा, सपोज टू बी ये रेडियस आर निकालते हैं अपन. And what is the time period? That is what we have to calculate. Time period, frequency. Now, who is providing the necessary centripetal force over here? It is the magnetic force which is providing the necessary centripetal force. So, magnetic force is equal to the centripetal force. What is the magnetic force? It is QVB. And what is the centripetal force? It is mv square by r. So, this v cancel. So, v we have is QBr by m. And once we got the v, right, once we got the v, we can calculate the time period, and time period is 2 pi r, that is what distance traveled by particle in one complete circle divided by the velocity is v. So if you just solve this, 2 pi r divided by q b r divided by m, this r will get cancelled and m will go into the numerator, and time period ka formula will have 2 pi m divided by qb. And frequency is 1 by time period, so it will be qb divided by 2 pi m. So this is what you have to remember. ठीक है ना? Next one we have, that is the fourth formula, the Biot-Savart law. The Biot-Savart law. And what is that law? It gives the magnitude of magnetic field due to the current carrying element, we can say. So if you have the current carrying element ideal, this is the current element, we can say. And if you want what is called as the magnetic field at a distance of r bar, supposed to be at a position vector of r bar from this ideal vector, then due to this ideal vector, the magnetic field will be into the plane, and that smallest magnetic field dB bar is equal to, we can have, and equal to mu naught, bolo. It's a Biot-Savart law, it's not bold, it is a printing mistake over there, okay? Yes. किसमें? उसमें मैंने बोला था तुझे कि एक्चुअल में बायट-सावर्ट लॉ तूने पढ़ा होगा इन मूविंग चार्जेस एंड मैग्नेटिज्म, ठीक है? हाँ था. सो इट इज म्यू नॉट आई डीएल बार क्रॉस आर बार. इसका मतलब तूने फर्स्ट टाइम सुन रही है. हाँ, तो बोल्ट-सावर्ट लॉ हाउ कैन यू से देन? अरे लेकिन तुझे पता होना चाहिए ना, इट्स नॉट अ बोल्ट-सावर्ट लॉ, राइट? इट्स अ बायट-सावर्ट लॉ. तो पहले पढ़ा होता तो तुझे पता होता. है ना? ठीक है. So it's a printing mistake. So dB bar is equal to mu naught I dl bar cross r bar divided by 4 pi r cube. This is the Biot-Savart law, and as it is you have to remember it. ठीक है? And this direction of the magnetic field is given by the direction of the magnetic field is given by right hand thumb rule. Next one we have is fifth formula, and that is magnetic induction at a point P. The magnetic induction at a point P due to finite current carrying conductor. तो अगर एक फाइनाइट करंट कैरिंग कंडक्टर है हमारे पास और विच इज और हमको निकालना है मैग्नेटिक फील्ड एट अ डिस्टेंस डी, और ये जो अपर एंड है इट इज मेकिंग एन एंगल ऑफ अल्फा एंड लोअर एंड इज मेकिंग एन एंगल बीटा सपोज टू बी. तो यहाँ पर दिस एंगल वी हैव इज अल्फा एंड दिस एंगल वी हैव इज बीटा. So magnetic field at this point we can write due to this finite current carrying conductor as mu naught I divided by 4 pi d in bracket sin alpha plus sin beta. All the terms are very very important. Ki what is I? I is the current in the conductor. Current in the conductor. What is d? Perpendicular distance from the conductor. Alpha is the angle from the perpendicular to upper end. Beta is the angle from the perpendicular to the lower end. So all these terms are very very important. Due to magnetic induction, एक्चुअली अब यहाँ पर इंडक्शन बोलेंगे अपन, मैग्नेटिक इंडक्शन ड्यू टू लॉन्ग स्ट्रीट करंट कैरिंग कंडक्टर. It will be B is equal to mu naught I divided by 2 pi d. So अगर एक लॉन्ग करंट कैरिंग कंडक्टर है, it is going towards infinity and it is going towards infinity, and we want at a distance d what will be the magnetic field at this point. So by using the above formula we can easily conclude that कि magnetic induction at a distance d due to a current carrying conductor is mu naught I divided by 2 pi d. Next formula we have, and that is magnetic induction due to circular coil which carries a current I and on the axis. तो अगर एक करंट कैरिंग सर्कुलर कॉइल भी have, and if you want what is the magnetic field on the axis at a distance d, जिसकी radius is given a supposed to be, so at this point what is the magnetic field? It will be mu naught I into a squared divided by twice of a squared plus d squared whole raised to 3 by 2. So don't remember only one formula, and that is in terms of magnetic moment. You can actually conclude, or you can actually find by just multiplying pi over here and pi over here. So pi a square will become the area, I into a will be the moment, what is called as the magnetic moment. So this is how you can actually find out. तो उसकी ज़रूरत नहीं है, बस ये फॉर्मूला यू हैव टू रिमेंबर कि म्यू नॉट आई ए स्क्वायर डिवाइड बाय ट्वाइस ऑफ ए स्क्वायर प्लस डी स्क्वायर होल रेज़ टू 3/2. तो दिस इज फॉर सिंगलटन. दिस इज फॉर सिंगलटन. अगर सिर्फ और सिर्फ एक सिंगल टर्न है, लेकिन अगर सपोज टू बी वी हैव द मल्टीपल टर्न्स और n टर्न्स, then what is the formula? So B for n turns will be n times the B for singleton. So it will be n into mu naught I a squared divided by 2 times a squared plus d squared whole raised to 3/2. बस इसको याद रखो. Next one we have eighth formula. Magnetic induction at the center of circular coil. Magnetic induction at the center of circular current carrying coil. So it will be B is equal to mu naught I divided by 2 into R. So if you have a current carrying coil over here like this, and which has a radius of capital R supposed to be, and which carries a current I. So by using right hand rule we can calculate that at the center the magnetic field will be into the plane, and its magnitude will be mu naught I divided by 2R. So this is the formula, and this is for singleton. As you can see, this is for singleton. So अगर n टर्न्स होंगे तो क्या हो जाएगा, बोलो सांझ. For n टर्न्स क्या हो जाएगा? B for n turns will be n times the B for singleton. So it will be n times mu naught I divided by 2R. आया समझ में? Ninth formula now. Magnetic induction due to circular arc. Magnetic induction due to circular arc at the center. तो अगर circular arc दिया है, circular arc as in somewhat like this, it is given, and we want what is the magnetic field at the center of this circular arc. So B. So it will be B is equal to, do remember, it is mu naught I divided by 4 pi r into theta. So do remember in one format only, see what is the magnetic field due to circular arc at the center, it is mu naught I divided by 4 pi r into theta. So simply you can use this formula and you can find easily. Now Ampere Circuited Law. तो देखो what does it says कि the closed loop integral, closed loop, it's not surface now, closed loop integral of b bar dot dl bar is always equal to mu naught times the current in, है ना, मतलब जितना करंट उस लूप में है, राइट। अगर सपोज टू बी एक लूप कंसिडर किया हमने, इस लूप में एक करंट ऐसे जा रहा है, फिर एक करंट इन मतलब सपोज टू बी, मैं इसको इनटू एंड आउट ऑफ नहीं लेता, डायरेक्टली ऐसे ले लेते हैं, एक ऊपर जा रहा है, फिर एक नीचे जा रहा है, फिर से एक ऊपर जा रहा है। तो ये अगर मैं कंसिडर करूँ I1, ये अगर मैं कंसिडर करूँ I2, ये अगर कंसिडर करूँ I3, तो कैन वी से दैट कि मैग्नेटिक फील्ड अगर इस लूप पे निकालनी है तो इंटीग्रल the magnetic field times the dl bar is always equal to mu naught times the in, जितना करंट अंदर है। तो what is the current inside, it is I1 ऊपर की तरफ, I2 नीचे की तरफ, I3 ऊपर की तरफ। तो ऊपर वाले डायरेक्शन को पॉजिटिव मान रहा हूँ, नीचे वाले डायरेक्शन को नेगेटिव, सो I1 माइनस I2 प्लस I3। तो इस डायरेक्शन में अगर यहाँ पर मैग्नेटिक फील्ड निकालनी है तो व्हाट वी हैव टू डू कि I1 की वजह से इन द सेम डायरेक्शन सपोज टू बी लूप की भी सेंस में हम लेंगे तो इट विल बिकम B इनटू इट इज 2 पाई R विच इज इक्वल टू म्यू नॉट I1 माइनस I2 प्लस I3। तो जो मैग्नेटिक फील्ड है B वो हो जाएगा म्यू नॉट I1 माइनस I2 प्लस I3 डिवाइडेड बाई 2 पाई R। तो इतना सिंपली हम निकाल सकते हैं मैग्नेटिक फील्ड ऑन द लूप। So this is what the Ampere Circuited Law, and it says that closed loop integral of b bar dot dl bar is always equal to mu naught into I n. So ये 10वां फॉर्मूला है हमारा। Next one we have, and that is 11th one, magnetic induction inside and at the ends of current carrying solenoid। तो करंट कैरिंग सोलेनॉइड के अंदर और at the ends what will be the magnetic field, वो हमको निकालना है। तो ये करंट यहाँ से आ रहा है सपोज टू बी, फिर ऐसे, फिर ऐसे, फिर ऐसे, दिस इज दी, दीज आर द नंबर ऑफ लूप्स वी कैन से, बहुत सारे लूप्स है ऐसे। यहाँ से करंट ऐसे ऊपर आ रहा है, फिर यहाँ से ऊपर, फिर यहाँ से ऊपर, ऐसे जाते 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 वी हैव द करंट सपोज टू बी। हमको निकालना है इस A पॉइंट पे एंड एट द एजेस B एंड C पॉइंट पे। तो मैग्नेटिक फील्ड एट A पॉइंट विल बी म्यू नॉट NI डिवाइडेड बाय 1 एंड मैग्नेटिक फील्ड एट द ends B and BC supposed to be, it will be mu naught NI divided by 2। तो बस ये दो formulas you have to remember। and what is mu naught over here? Permeability of free space। its value is 4 pi into 10 to the power minus 7 Henry per meter। then we have N is number of turns per unit length, number of turns per unit length, and I is the current in the solenoid। The next one we have the magnetic induction inside the toroid is, तो अगर एक टोरॉइड हम कंसिडर करें तो ऐसा कुछ toroid we have, so अगर यहाँ पर किसी भी पॉइंट पे इनसाइड इफ यू कंसिडर at A or B magnetic field at A which is equal to magnetic field at B and that is equal to mu naught Ni, same like the solenoid. Again, do remember magnetic field induction outside the toroid is always zero. Magnetic induction outside the toroid is always zero. 14th one now. The ratio of magnetic moment to the angular momentum is called as the gyromagnetic ratio, right? Gyromagnetic या gyromagnetic, that is the different pronunciation we have. So the ratio of magnetic moment to the angular momentum is called as gyromagnetic ratio, and this gyromagnetic ratio we have is capital M divided by I. This is the magnetic moment to the current, and it is always equal to the charge on electron divided by 2m. Charge on electron divided by 2m. So for electron, so this magnetic moment to the current की value is 8.8 into 10 to the power 10 coulomb per kg. Coulomb per kg. हो गया. इसके बाद we have the 16th one, torque on a current loop is tau bar is equal to m bar cross b bar, and that is equal to, we can write mb sin theta, mb sin theta into n hat, and that is equal to m is ia, so it is nia into b sin theta, we can say. So do remember it is into n hat. Do remember this formula. उसके बाद we have, and that is force per unit length, force per unit length due to one current carrying conductor on the other is, तो अगर एक करंट कैरिंग कंडक्टर है विच कैरीज द करंट I1 सपोज टू बी, एंड ये I2 के ऊपर जो भी फोर्स लगाएगा I1 की वजह से जो मैग्नेटिक फील्ड होगी वो नीचे की तरफ होगी और इनटू द प्लेन बोल सकते हैं. सो फोर्स ऑन इट विल बी, सो फोर्स ऑन द सेकेंड इट विल बी P1 magnetic field, I2 current into the length. So it will be force per unit length we have. B1 is mu naught I1 I2 divided by whatever the 2 pi d is there. So d is the distance between the two current carrying conductors. So this is the force per unit length का formula. Mu naught I1 I2 divided by 2 pi d. Force per unit length is mu naught I1 I2 divided by 2 pi d. Next one we have, and that is 18th one, current sensitivity. A current sensitivity is theta divided by I, and that is equal to NAB divided by K. So N is number of turns, A is area of cross section, and B is the magnetic field, magnetic induction, K is the couple per unit twist. K couple per unit twist. And the last formula we have, and that is voltage sensitivity. देखो करंट सेंसिटिविटी को करंट कितना, मतलब थोड़ा सा करंट चेंज होने में थीटा एंगल कितना चेंज हो रहा है, दैट इज व्हाट द करंट सेंसिटिव मीन. सो एंगल कितना चेंज होगा बाय चेंजिंग द वोल्टेज, दैट इज व्हाट द वोल्टेज सेंसिटिविटी इज. सो इट विल बी, so we can write theta divided by I into R, so which is theta by I is current sensitivity, it will be NAB divided by K into R. Formula will be the same. So अगर मैग्नेटिक फील्ड, मैग्नेटिक इंडक्शन सेंसिटिविटी होता तो थीटा बाई बी होता, इलेक्ट्रिक सेंसिटिविटी होता तो थीटा बाई ई होता. सो लाइक वाइज अकॉर्डिंगली आवर फॉर्मूला विल चेंज. So theta by I is the current sensitivity, theta by V is the voltage sensitivity.